All right, so 3-4 is called solving exponential and logarithmic equations. Yep. Which is exactly what it is. So these are going to have some sort of equal sign in them because you're going to be solving. So there's going to be logs mixed in with exponentials, ln's, and e's, all kind of mixed into this together. Obviously, if it says the word solve, you got to make sure that you solve for the variable. So we're going to start with the exponential equations. And some of these we've done, okay? If you're solving for, if it's an exponential equation, meaning the word log is not in it, okay? Then you're going to change the base to be the same using the one-to-one property. Or you're going to take the ln or natural log of both sides of your equations. So the first kind we've done before, if I had like 2 to the x equals 8, I would rewrite it as 2 to the x equals 2 to the third, change it so that the base is the same, and I would get x equals 3. So kind of basic. Obviously, we're going to go a little bit further, but that's the concept of the first one. If you can change the base on either side of the equal side to be the same, you do. You set the exponents equal to each other. If you can't change the base on either side to equal each other, and it would be something like, I don't know, 2 to the x equals 3. There's no way to rewrite 3 as a power of 2. So this is when we actually make ln a verb. We ln both sides of my equation. So I'm going to ln this side and I'm going to ln this side. So it looks like ln of 2 to the x equals ln of 3. Now here comes our rules of expansion. If I wanted to get rid of that exponent, if I wanted to move that x, where does it go? Goes to the front. So this becomes x times ln of 2 equals ln of 3, and then I would divide both sides by the ln of 2. And I would use the calculator to find ln of 3 divided by ln of 2. (1.5849), which is 5. So 2 different types of exponentials. Either you can change the base to be the same. Those would be without a calculator. So you change the base to be the same, and then you set the exponents equal to each other. The second kind is if you cannot change the base to be the same, one is not the power of another. You would ln both sides of your equation. You would solve for x, and that's going to involve the calculator. I went kind of easy on you with the rounding yesterday on the quiz, but I will stick to it for the test. If it says 3 decimal places and you give me 4, you're going to get docked points. Pay attention to the instructions. If it says 10th, obviously 1. If it's money, 2. I think there was only like one person throughout the day that didn't round the money to the right digit. But money would be 2 digits. All right, so A, well, they all say solve for x. Let's look at A. So is there a common base there? Is there something I can raise to a power to get 64 and also get 32? What is it? 2. Good. So if you don't know it, this would be 8 and 8, right? Which would be 2 and 4, 2 and 2, 2 and 4, 2 and 2. That's 1, 2, 3, 4, 5, 6 2s. So this is 2 to the 6th. Oh, that's really hard to read, sorry. 2 to the 6th raised to the 3x, because that one was originally there. 32 is 1 less 2, so 2 and 16, 2 and 8, 2 and 4, 2 and 2, 1, 2, 3, 4, 5 2s, so 2 to the 5th raised to the 2 plus x. Now what do we do when we raise a power to a power? Multiply. So this becomes 2 to the 18x, and this gets distributed to both. This becomes 2 to the 10 plus 5x. Now the bases are the same, so I can set my exponents equal to each other. 18x would equal 10 plus 5x. I'd subtract the 5x. 13x would equal 10, and divide both sides by 13. And x is 10 over 13. Notice we didn't use the calculator at all. That would be on that part of your test without a calculator. Yep. Yeah. Yep.
So we wouldn't make them decimal on the test?
No, you won't. You wouldn't. like, no, 1, that wouldn't be it. That would never terminate. But yeah, no, you don't want to. Okay, B. Can I change them both to have the same base?
Yes.
Yeah, what am I moving? Or what can I move? Because it doesn't have to do this, but what? This goes to the top, right? And it would be what?
5 to the negative 3.
Good. So 5 to the negative 3 equals 5 to the 2x. Just set my exponents equal to each other. 2x equals negative 3 divided by 2. And x equals negative 3 halves. Okay, now I get to exponential involving e, okay? So let's say we're going to start by isolating the e, because that's what I would want to do. I would add 9 to both sides of these. Is there a way to change those both to the same base? No, right? So then we ln. Good. We can't change them both to the same base. And when we're involving e, so we ln both sides of this equation. So ln of e to the x would equal ln of 28.
Wouldn't you just cross out the LN?
Good. So you have two choices here. One, bump the x to the front, right? And then divide by ln of e. But what is ln of e?
1.
It's just 1. Or if I kept the exponent, I cancel it and just keep the exponent. So x would equal ln of 28. So without a calculator, you would leave that answer the way that it is. If this is on the part with the calculator, you would answer it as though it's ln 28, which is 3.332. So remember, ln of e cancels to give you the exponent. So you can either push that to the front, and it would be x times ln of e equals ln of 28. This is 1, so I'd get x equals ln of 28. Or save yourself that work and realize as soon as you get ln of e to a power, you can cancel out what's there and keep just the exponent. Yeah.
What days next week are our tests?
Tuesday.
Tuesday. Okay, so it's just.
It's all on Tuesday.
Okay.
Yeah, you just get it in 2 parts. Like the last time, you know, when I gave you the colored paper one for, yeah, it's just like that. All right, D, can I change these to be the same base? No, which means I'm going to ln both sides of my equation. So I get ln of e to the x equals ln of 4, which means x equals ln of 4. Without a calculator, it would stay like that. With a calculator, it would be 1.386. So without and with. Questions so far? All right, do 7, or try A. All right, so same set of instructions. Solve the equation, round to 3 decimal places. So I know I'm using the calculator. For A, 7 minus 2 to the 2 times e to the x equals 5. First thing you got to do is get rid of the 7, so I have to isolate that e. This would be negative 2. I would divide both sides by negative 2. E to the x equals 1. Now I ln both sides of the equation. And I get x equals ln of 1. What happens when you type that in the calculator?
0.
You get 0. So if you caught it from here, any exponential, right, equals to 1 means the power has to be 0. So you could also catch it there. Okay, so B is a little bit different. B is actually a factoring statement disguised as e's. So what we can do here, you have basically 2 options. One is substitute like something, another variable, let's just say like A, as my middle term. And I would get this squared minus A minus 12 equals 0. And I could factor it, A minus 4 and A plus 3. And then I could solve it. A equals 4 and A equals negative 3. But then I substituted A for e to the x, so I have to substitute e to the x back in for A, e to the x. And then ln, both sides of your equation. ln of e to the x equals x. So x would equal ln of 4, which is 1.386. And then ln of e to the x is x equals ln of negative 3. What happens when you try to do that in the calculator? Can you find the log of a negative number?
Number.
So I cancel that root out. It's an extraneous root, okay? You cannot find the log, which means ln, of a negative number. So this would be my only answer. The other option here is to keep it as it was at the beginning. And factor it. So the first term, e to the 2x squared rooted is e to the x. So they both get an e to the x. And then I look at the last term, factors of negative 12 that sum to the negative 1 would still be negative 4 and positive 3. Set them each equal to 0. E to the x equals 4. E to the x equals negative 3. ln both sides of the equation. This cancels, x equals ln of 4. This cancels, x equals ln negative 3. So you get the same answer either way. However your brain sees it is what you want to stick to. So when you've got an e to the 2x and an e to the x, it's really just a factored statement. Or factoring statement, something you have to factor. All right, now we're going to solve log functions, and I would know that they are a log function because the word log will literally be in the question. Either the word log or the ln, because that's also a log. So if there's only one log, I'm going to make sure I isolate that log, and then I'm going to put my equation into exponential form and solve it the way we just did. If there's one ln, I'm going to change that ln to be log base e. And then I'm going to put it into exponential form. So the first one, you had something, so well, actually, I don't remember what version you had. But let's say we had this on our quiz. We had log base 2 of x equals 3. Then this simply means make the 2, pick up the 3. 2 to the 3 would equal x, and my answer is 8. That's what that would look like, okay? If it was ln, it would be ln of x equals 3. I would rewrite it as log base e of x equals 3, and then e would come over and pick up the 3, and I would put that in the calculator because that would be that kind of question. E to the third, which would be 20.086. So those are the first two kinds, if you just have one log or if you just have one ln. The third kind is if you have one log on either side of the equal sign. So this is a log or an ln because it could be the same thing. On either side of the equal sign. For these, you're going to use the one-to-one property to solve it. So that could look something like this. Log of x plus 3 equals log of 2x minus 5. And then because they have the log on either side of the equal sign, I just set them equal to each other. Subtract the x, add the 5. Same exact thing would happen if those were both ln's. If I had ln of x plus 3 equals ln of 2x plus minus 5, I'd get the same answer. As long as it's the same log on either side of the equal sign. Okay, the next kind is if there's multiple logs slash ln's, because those are also logs, on either side of the equal sign. So if on either side of the equal sign I have two logs, okay, or two ln's, then you are first going to condense those down to one statement using your properties of logs. So if it was addition, when it's expanded, when I condense it, I'm going to multiply. If it's subtraction, I'm going to divide. I'm going to get it to the point that there's either one log on either side of the equal sign. So then I would use the 1 to 1. Or there's only one log now on one side, and so I can put it into exponential. So the difference of those would be like this. So if I had log of x plus log of 3 equals 10. It's a really big number, but I'm just making stuff up. I would condense the left side, so this would be log of 3x. Because when we condense, we multiply, right? If it was addition, we multiply. What's the base on that log? 10. So this would now become 10 to the 10th. Watch the way I said that's a big number. Equals 3x. That would be 10 with 10 zeros. You won't get a number that big, but let's just say you did. And then I would take whatever that is, the 10 zeros. I'm too lazy to write that all the way out. 10 to the 10th, and I would divide it by 3. So that's if there's only logs on one side of the equal sign. We condense, we get it into exponential. Now, if there was logs on both sides of the equal sign, let me pick a different number because that actually simplifies. I have log of x plus log of 3 equals log of 8. So I got to condense the left side of this. Again, it's addition, which means it becomes multiplication. And then I have the log with the same base, because those would both be log base 10 on either side of the equal sign. So I disregard the logs, and I set 3x equal to 8, and I would get x equals 8/3. Okay, now here's what's super important. If your initial question starts with a log in it, whether it be a log or an ln, you have to check your answers. You have to make sure that when you plug them back in, you would not be trying to find the log of 0 or the log of a negative number. If when you plug it back in, you're trying to find log of 0, you can't find it. You would rule that out. It's an extraneous root. If when you plug it back in, you're trying to find log of a negative number, you rule it out because you cannot find the log of a negative number. Now, this does not mean every negative and every 0 answer is wrong, because when you plug it back in, it might change it. So, I mean, I'll kind of show you what I mean when I get to that. I think it's easier to see it. But you have to make sure you check. So anything that starts with a log or an ln, you have to check your answer. Not to make sure it's right, but to make sure it's not extraneous. All right, let's see what we got. So example 3 says solve the log equation algebraically and then approximate the result to 3 decimal places. So what are we going to do with A? And actually this one you wouldn't need a calculator for, but let's just keep going. Good. I've got one log. The base isn't there yet, which means it's 10. 10 comes over and picks up the 2, drops off leaving the 5x. That means 100 equals 5x. Divide both sides by 5, and x is 20. Now, does my original question have a log or an ln in it? Yes, which means I have to check. So I'm going to take that 20, I'm going to plug it back in. If I multiplied that out, I'd end up with log of 5 times 20, which is log of 100. If you wanted to know for sure you're right, you would actually find that. But for right now, the check is just to make sure that once we plug that back in and simplified what was next to the log, it's not 0 or negative. And it's not. It's a positive 100. So I get to keep this answer. Go to B. How many logs are there? 1. So what do we do?
Subtract 5 and you move the 2 over the...
Good. We're going to isolate it. So subtract the 5 from both sides. 2 ln of x equals 9. Then divide by 2. And I get, what is ln?
Log e of x.
Good. Log base e of x equals 9 over 2. And you can leave it as 9 over 2. You could rewrite it as 4.5, 4.5. Doesn't matter. But you could leave it. Now what?
You don't have to move the 2 over the x.
No, this is multiplication. I just divided by it, so it cancels out.
You have to make ln log v.
I mean, you don't have to rewrite it, but you got to know that that's what it is because now I've got to raise e to that power. Yeah. So e to the 9/2 equals x. Again, without a calculator, it would stay like that, but with a calculator, which is most likely going to happen when you have an e, it would be e to the 9/2, and that is 90.017. Does my initial question have a log or an ln in it? Yep, so I'm going to check. I'm going to take this and plug it back in. I'd be finding ln of a positive number, which is completely fine, so I keep that answer. Example 4, solve the equation algebraically, round to 3 decimal places. So look at A. What do we have? Good. Log base e of x equals -3. One log. E's going to come over and pick up the -3. And then e to the -3 is 0.497. Wait, 0.0497. So the 7 rounds up the 9, the 9 rounds up the 4. You don't need that last 0, okay? But you can also put it. And we go to B. What's happening here? I have to condense it. So on the left-hand side, the condensing happens, the plus is there, which means what when I condense? Good. So I'd end up with log base 3 of x times x minus 2 equals log base 3 of x plus 4. Now there's one log on either side of the equal sign, right? So I ignore the log. I take what's next to it. I set it equal to each other. On the left-hand side, I have to distribute the x in. Now what? What do you do when you see an x and an x squared? Adam.
So from here, would you subtract from x and then subtract 4 and then and then go where?
You're going to factor. So like as soon as you see an x and an x squared, know to get everything to one side of my equal sign because you're going to have to factor. So what are the factors of -4 that sum to -3? Good. Split and solve, and I get x equals 4 and x equals -1. Now my original question had the log in it, which I actually didn't check this one. I should have done that too, but it would have been fine. But I have a log in it, so I know I have to check these answers. So I'm going to check the 4. If I take 4 and I plug it in here, would I be able to find log base 3 of 4?
Yeah.
Yes. If I take 4 and plug it in here, I'd get 4 minus 2, which is 2. Would I be able to find log base 3 of 2?
Yeah.
Yes. If I take 4 and plug it in here, I get 4 plus 4, which is 8. Would I be able to find log base 3 of 8?
Yeah.
Yes. So the x equals 4 stays. Then I check the -1. If I were to plug -1 into that first one, I would be trying to find, hang on, log base 3 of -1. Would I be able to do that? No. If it doesn't work for even just one of them, it's a no. I rule it out, okay? If it worked for all but one, I rule it out. If it works for none, obviously you still rule it out. Which means the only answer I can keep here is 4. So you've got to check anything that starts with the word log or ln. And you want to check all the spots. So again, if it had worked for the first one but not the second one, then I would still rule it out. So what changes if I had this same equation, but it said log base 3 of x minus log base 3 of x minus 2 equals log base 3 of x plus 4? What changes here? When I subtract, I divide. So this would be log base 3 of x over x minus 2 equals log base 3 of x plus 4. And then there's a log on either side of the equal sign, so I'd get x over x minus 2 equals x plus 4. I don't know that these numbers work out, so I don't want to keep going, but what would you do from there?
Multiply with x minus 2.
Good. Like I said, I don't know if we're going to actually get to an answer because I just made that up. But then I would get this, and then I would FOIL the right-hand side, and then I would subtract the x. And then if that was actually factorable, I would factor and get the remaining 2. Technically, I could do the quadratic on that to get the roots. You won't have to do that. It would be factorable at that point. And then I would make sure I checked it, okay? So you could see condensing with addition. You could see condensing with subtraction. You could also see condensing without something on this side. So that's the other variation of it, and it's not in here, but I think it's on the homework, so let me just rewrite that out too. Log base 3 of x plus log base 3 of x minus 2 equals 4. So if there's not a log on the right-hand side, I start the same way. I would condense the left side. Log base 3 of x times x minus 2 equals 4. And then how does it change from here? Good. I change it to exponential. I can't make it 1-to-1 because there's not a log on the other side. So then the 3 comes over and picks up the 4. And I'd get, this is 243. X squared minus 2x. And then I would move this to the other side. And if it was factorable, I would factor it. Okay. Again, I just made that up, so it's not going to make sense. But is that right? No, it's 81. Just kidding. I did one too many. Questions on any of the examples from today? I would say the hardest part of this section is knowing what to do when. So you just got to strategize.